In this video, we will share our perspective of engine displacement in LEGO minifigure scale. Let's start by measuring volume as related to a cube. To calculate the volume of a cube, we will measure the length times width times height. If each of these dimensions is 1 inch, then the cube will have a volume of 1 cubic inch. If each of these dimensions is 1 centimeter, then the cube will have a volume of 1 cubic centimeter. As a side note, 1,000 cubic centimeters is equal to 1 liter. As seen, we now have illustrations for 1 cubic inch and 1 cubic centimeter. Now that we've defined our units of measurement for volume of a cube, we'll talk about the volume of a cylinder or cylinder volume. Cylinder volume is the volume in a single cylinder that is displaced with a piston. In this view, we see a LEGO Technic engine block with the cylinder. The part can be identified as Technic Engine Cylinder 2850. To calculate cylinder volume, we will need the measurements for the bore of the cylinder and the stroke of the piston. The bore is the diameter of the cylinder. We will measure the bore of the cylinder on this LEGO Technic piece. As seen, the bore of the cylinder is 9.55 mm or 0.376 inches. Next, we will measure the stroke using this LEGO engine assembly with 2 cylinders. Stroke is the measurement of height or distance that the piston moves between top dead center and bottom dead center. As a side note, top dead center is when the piston is at the top of its stroke, and bottom dead center is when the piston is at the bottom of its stroke. The engine assembly includes LEGO Technic pistons. The piston can be identified as Technic Engine Piston Round 2851. This LEGO assembly will allow the pistons to move up to top dead center and then down to bottom dead center. Now we will measure the stroke of the cylinder on this LEGO Technic piece. Because I do not have a tool small enough to fit inside the cylinder, I'll use a stick to help us measure. This may not be exact, but it'll give us a good idea to demonstrate the concept. We will mark the stick at bottom dead center. We will now mark the stick at top dead center. As seen, the measurement is 8.4 millimeters. Considering that there are pen marks and this is not exact, let's round this out to 8 millimeters or 0.315 inches. Now that we have our measurements, let's start to look at the data to estimate engine displacement. As seen, we measured a bore of 9.55 millimeters or 0.376 inches. We also measured a stroke of 8 millimeter or 0.315 inches. As a throwback, we can recall that the volume for the cube was measured with 3 dimensions. Volume for the cylinder will only need 2 measurements because the bore is a circle. With the area for a circle or volume for a cylinder, we can use pi, which can be shortened to 3.14. Pi is the ratio of a circle's circumference to its diameter. You'll see pi in the formula that we're going to use to estimate engine displacement. Seen here is one formula to calculate engine displacement. Engine displacement is the total cylinder volume including all cylinders in a piston engine. To keep this simple, we will say that we're only measuring the engine displacement for one cylinder. We can see that this formula includes pi to help calculate the cylinder volume. If we simplified this formula, it would read as displacement equals cylinder volume multiplied by the number of cylinders. So now using the measurements in the formula, we can estimate the displacement. The displacement for a 1-cylinder LEGO Technic engine is 0.573 cubic centimeters or 0.0349 cubic inches. From our previous video, we chose LEGO minifigure scale to be 1 to 42.5. Our perspective about LEGO minifigure scale can be seen in that video, which will be linked in the description. This table demonstrates the dimensions for our 1-cylinder LEGO Technic engine converted into LEGO minifigure scale. As seen with just 1 cylinder, the engine would be 43.9899 liters or 2,684.9915 cubic inches. A 43.9 liter 1-cylinder engine may seem extreme, but as seen in these views, the engine is large in comparison to the minifigure. So now that we estimated our engine displacement for the LEGO Technic engine, let's use a 1x1 brick. This view shows a comparison of the two pieces. Although the 1x1 brick does not have a cylinder or piston inside it, we can still use it in a small build to represent the exterior of an engine block. You'll notice that the stud at the top of the Lego is a cylinder shape. In this view, we can see the dimensions for the 1x1 Lego brick. We know that our cylinder could not be no more than 7.8 millimeters since that is the max width of the brick itself. We can use the diameter of the stud to represent our theoretical cylinder diameter. This would mean our theoretical cylinder would be cut into the brick rather than a stud sticking out on the top. The measurement of our bore could match our stud at 4.8 millimeters or 0.1921 inches. Since this example is theoretical, we'll illustrate a piston inside the 1x1 brick. As seen, the brick without the stud has a max height of 9.6 millimeter. To make things simple, we'll say that this piston has a stroke of 4 millimeters or 0.1575 inches. Now let's estimate the displacement for our theoretical Lego 1x1 brick. As seen, our theoretical one-cylinder engine for the 1x1 brick would have a displacement of 0.0748 cubic centimeters or 0.0046 cubic inches. When we convert the measurements to minifigure scale, this would mean our one-cylinder engine would be 5.74323 liters or 350.42248 cubic inches. Keep in mind that a real example of a 5.7 liter or 350 cubic inch engine would be the GM or Chevrolet small block with 8 cylinders. These are interesting theories, but as we all know, Legos are left to the imagination. That being said, the 1x1 block could be almost any displacement that is less than the maximum dimensions for the brick. Since our first two example engines were large, we'll consider our imagination to come up with a completely theoretical example. Shown here is a Lego minifigure. The gap in the hand of the minifigure is 2 millimeters or 0.07874 inches. Let's use the measurement of the gap in the hand as our theoretical bore. To keep this simple, we'll define our theoretical stroke as 1.75 millimeters or 0.0689 inches. Illustrations of a cylinder and piston were added to give a representation of how small this theoretical engine would be compared to the Lego minifigure. With the data in this table, we can see that one cylinder of our theoretical engine would have the displacement of 0.00549 cubic centimeters or 0.0003355 cubic inches. If we converted that one cylinder to minifigure scale, it would then have a displacement of 0.4522 liters or 25.7553 cubic inches. Now, if this example was a 4-cylinder engine and converted to minifigure scale, it would be 1.68864 liters or 103.0212241 cubic inches. The displacement of 1.68 liters or 103 cubic inches could be a small 4-cylinder automotive engine. Although theoretical, this last engine does give an example for the size of a piston as compared to the size of the gap in the Lego minifigure hand. This finishes our discussion and the BrikBarn perspective on engine displacement as related to scale and Lego minifigure scale. Thank you for watching.